Okay, Algebra 2 students, here is the first video for lesson 4.3. We're going to multiply and divide rational expressions. How does understanding operations with fractions help you multiply and divide rational expressions? And in the end, you're going to be able to find the product and quotient of rational expressions. Going to the first example, we have, before we do, we have a concept. A rational expression is the quotient of two polynomials. The domain is all real numbers except for those in which the denominator is equal to 0. So we've had this before. That concept isn't new, so I'm just going to move on. Writing equivalent rational expressions. When are two rational expressions equivalent? Write the expression that is equivalent to that mess there. Okay, we want to, hopefully you're good at factoring. For example, like if we have 12 divided by 16, 12 is 3 times 2 times 2, and 16 is 2 times 2 times 2 times 2. So you can cancel out those 2's, and you're left behind with 3 over 2 times 2. 3 over 2 times 2 is 3/4. So 12/16 is the same as 3/4. So we're going to find common factors in these two puppies and reduce it, essentially. Okay? First, you got to factor the numerator and the denominator. The numerator has x's for all three terms, so they factor out an x. The denominator had x's in all three terms, so they factored out an x. In the numerator, they were left with x squared minus 5x minus 24, which factors into minus 8 and plus 3. Remember, it's as long as the leading coefficient is 1, we can just say factors of negative 12, that when you add them, you get negative 5. Negative 72 factors into minus 8 and plus 9. Now, you can see we have x and x, and we have x minus 8 and x minus 8. Oh, before we do that, we need to look at the domain, because we don't want to cancel them out because they're still important. X could equal 0, x could equal 8, and x could equal negative 9. Those are the three values that don't work for the domain. So the domain is all reals except for 0, 8, and negative 9. Then you can reduce it by getting rid of the x over x and the x minus 8 over x minus 8 to get just x plus 3 over x plus 9, because the other ones cancel it out. However, we have to remember these values in the domain. We have to remember those. Even though they don't show up, only negative 9 shows up as a possible restriction on the domain. We still have to go with the original 3. So final answer is that original fraction is equivalent to this one, which is not highlighting, for all values except for x except for negative 9, 0, and 8. Okay? Do you think that's all right? Give that a shot by factoring that one down to its equivalent. And I'm going to try to do that right here. Click pause if you want to give it a shot yourself. All right, I can see that in the numerator I can take a x out of everything. Oh wow, it's x cubed. I can take an x cubed out of all of these. And a 3. 18 and 21 are both divided by 3. So in the numerator I got 3x cubed is coming out. And what I'm left behind with is an x squared minus 6x minus 7. And I'm going to stay here in the numerator because I still can factor that some more. So let me factor that. Factors of negative 7 that add up to negative 6. That would be, if you don't mind, I'm going to leave the 3x cubed way over there. That would be negative 7 and positive 1. So I have this in the numerator, I have this in the numerator, and I have this in the numerator. Now let me deal with the denominator. 2x to the 6 minus 98 x to the 4th. I can factor out an x to the 4th out of both and a 2. So I'm going to take out a 2x to the 4th out of both, and I'm going to be left with an x squared minus 49. And that's good because I can recognize that as the difference of squares. So that breaks down into x minus 7 and x plus 7. which makes sense. They wouldn't give us this problem without being able to reduce it. Well, they could, but typically they don't. All right, now these don't reduce very well. 3 over 2. Well, first let me look for the what the domain. The domain, we can't have it be 0. We can't have it be 7. It can't be negative 7. So let me write those over here. Can't have 0, negative 7, or 7. Those are restrictions on the domain. All right, and these cancel out. And the x to the third cancels out with all of them except for 1 here. So I still have 3 over 2x. So I still have a 3 over a 2x. And in the numerator, I have x plus 1. And in the denominator, I have x plus 7. Now, I'm going to stop there, but they may want you to expand that out, meaning 3x plus 3, and then the 2x squared plus 14x. But let's see what they wrote for an answer. They wrote it out like I did, 3 times x plus 1 over 2x plus x plus 7, and you can have 0, negative 7, or 7. Okay, hope that helps. That's it. Oh, let's see what problems we can do. Is this the first one? I think it was. So you can do those 7 problems right there from pages 215 to 216. That's it for this video. Have a great day.